All right, let's talk about functions in Python. So like with other languages, you can have functions that let you repeat a set of operations over and over again with different parameters. And in Python, the syntax for doing that looks like this. You declare a function using the def keyword. That just says this is a function, and we're going to call this function square it. And the parameter list is then followed inside parentheses, so this particular function only takes one parameter that we're going to call x. And again, remember, white space is important in Python. There's not going to be any curly brackets or anything enclosing this function. It's strictly defined by white space. So we have a colon that says that this function declaration line is over, but then it's the fact that it's tabbed by one or more tabs that tells the interpreter that we are in fact within the square it function. So def square it of x, colon, tab, return x times x, and that will return the square of x in this function. So we can go ahead and give that a try. Print square it 2 is how we call that function. Looks just like it would be in any other language really, and that should return the number 4. And in fact, it does. Awesome. So that's pretty simple. That's all there is to functions. Obviously, I could have more than one parameter if I wanted to, however many parameters as you need. Now, there are some weird things you can do with functions in Python that are kind of cool. So one thing you can do is pass functions around as though they were parameters. So let's take a close look at this example. So now I have a function called do something, def do something, and it takes two parameters, one that I'm calling f and one that I'm calling x. And if I can actually pass in a function for one of those parameters. So think about that for a minute. Look at this example, it'll make more sense. So do something f and x will return f of x. So it will basically call the f function with x as a parameter. And there's no, strong typing in Python, so we have to just kind of make sure that what we are passing in for that first parameter is in fact a function for this to work properly. And for example, we'll say print do something, and for the first parameter we'll pass in square it, which is actually another function, and the number 3. So what this should do is say do something with the function square it and the parameter 3, and that will return square it 3. And 3 squared last time I checked was 9, and sure enough that does in fact work. So that might be a little bit of a new concept to you, passing functions around as parameters. So if you need to stop for a minute there, pause and let that sink in, play around with it, please feel free to do so. Again, I encourage you to stop and take this at your own pace. One more thing that's kind of a Pythonish sort of a thing to do that you might not see in other languages is the concept of lambda functions. And it's kind of called functional programming. The idea is that you can inline a simple function into a function. So, for example, this makes the most sense with an example. We'll print do something, and remember our first parameter is a function. So we can actually, instead of passing in a named function, I can declare this function inline using the lambda keyword. So lambda basically means I'm defining an unnamed function that just exists for right now. It's transitory. And it takes a parameter x. So that's the syntax here. Lambda means I'm defining an inline function of some sort, followed by its parameter list. It has a single parameter x, and the colon, followed by what that function actually does. So I'm going to take the parameter x and multiply it by itself 3 times to basically get the cube of a parameter. So in this example, do something will pass in this lambda function as the first parameter, which computes the cube of x, and the parameter 3. So what's this really doing under the hood? This lambda function is a function of itself that gets passed in as f up here and do something, and x here is going to be 3. That will return f of x, which will end up executing our lambda function on the value 3. So that 3 goes into our x parameter, and our lambda function transforms that into 3 times 3 times 3, which is, of course, 27. Okay. Now this comes up a lot in when we start doing MapReduce and Spark and things like that. So if you're going to be dealing with Hadoop sorts of technologies later on, this is a very important concept to understand. Again, I encourage you to take a moment to let that sink in and understand what's going on there if you need to. Okay, we're good? If so, let's move on. Boolean expression syntax is a little bit weird, or unusual at least in Python. As usual, we have the double equal symbol that can test for equality between two values. So does 1 equal 3? No, it doesn't. But false, the value false, is the special value designated by capital F false. So remember, when you're trying to test, when you're doing Boolean stuff, the relevant keywords are true with a capital T and false with a capital F. That's a little bit different from other languages that I've worked with, so keep that in mind. Print true or false. Well, true or false is true because one of them's true. Comes back true. The other thing we can do is. So is sort of the same thing as equal. It's a more Pythonish representation of equality. So 1 equals 3 is the same thing as 1 is 3, but this is considered the more Pythonic way of doing it. So 1 is 3 comes back as false because 1 is not 3. And we can also do if-else and else-if blocks here too. So doing something a little bit more complicated here, if 1 is 3, I would print how did that happen? But of course 1 is not 3, so we fall back down to this else-if block. So otherwise, if 1 is not 3, we will test if 1 is greater than 3. Well, that's not true either, but if it did, we'd print yikes. And we will finally fall into this catch-all else clause that will print all is well with the world. In fact, 1 is not 3, nor is 1 greater than 3. And sure enough, all is well with the world. So, other languages have very similar syntax, but this is the peculiarities of Python and how to do an if-else or else-if block. Okay? So again, feel free to keep this notebook around. Might be good reference later on. Moving on to the last concept I want to cover in sort of our Python basics is looping, and we've seen a couple of examples of this already, but just to do another one. For example, we can use this range operator to automatically define a list of numbers in the range. So if we say for x in range 10 produces a list of 0 through 9. And by saying for x in that list, we will iterate through every individual entry in that list and print it out. And again, the comma after the print statement says, don't give me a new line, just keep on going. So the output of this ends up being all of the elements of that list printed next to each other. And to do something a little bit more complicated, we'll do something similar, but this time we're going to show how continue and break work. So as in other languages, you can actually choose to skip the rest of processing for a loop iteration or actually stop the iteration of the loop prematurely. So in this example, we're going to go through the values 0 through 9. And if we hit on the number 1, we will continue before we print it out. So we're going to skip the number 1 basically. And if the number is greater than 5, we're going to break the loop and just stop processing entirely. So the output that we expect is that we will print out the numbers 0 through 5, unless it's 1, in which case we're going to skip number 1. And sure enough, that's what it does. Another syntax is the while loop, kind of a standard looping syntax that you see in most languages. So we can also say start with x equal to 0, and while x is less than 10, print it out, and then increment x by 1. So this will go through over and over again, incrementing x until it's less than 10, at which point we break out of the while loop and we're done. So it does the same thing as this first example here, but just in a different style. Prints out the numbers 0 through 9 using a while loop. So just some examples there. Nothing too complicated. Again, if you've done any sort of programming or scripting before, this should be pretty simple. Now, to really let this sink in, I've been saying it throughout this entire lecture. Get in there, get your hands dirty, play with it. So I'm going to make you do it. Here's an activity, a little bit of a challenge for you. So here's a nice little code block here where you can start writing your own Python code and run it and play around with it. So please do so. And your challenge is to write some code that creates a list of integers, loops through each element of that list, pretty easy so far, and only prints out even numbers. Now this shouldn't be too hard. There are examples in this notebook of doing all of that stuff. All you have to do is put it together and get it to run. So the point is not to give you something that's hard. I just want you to actually get some confidence in writing your own Python code and actually running it and seeing it operate. So please do so. Definitely encourage you to be interactive here. If you do have any trouble with it, feel free to post in the discussions for this class, and I or one of the students will be happy to help you out. So have at it. Good luck and welcome to Python. So that's your Python crash course. Obviously just some very basic stuff there. As we go through more and more examples throughout the course, it'll make more and more sense since you have more examples to look at. But if you do feel a little bit intimidated at this point, maybe you're a little bit too new to programming or scripting, and it might be a good idea to go and take a Python course before moving forward. But if you feel pretty good about what you've seen so far, let's move ahead and we'll keep on going.